In this video, we're going to explain the difference between integrity and insulation when we're talking about fire resistance in passive fire protection, because there is a lot of confusion out there, and understanding the difference between these is very important, especially when it comes to your fire strategy, because whereas integrity is sometimes a lot easier to provide protection, insulation can be very difficult, and there's sometimes needing a lot more consideration and thought when you're planning your service penetrations, for example. So for this video, I am focusing on service penetrations because that is Qualifiers bread and butter. So we're looking at what integrity and insulation means when we're talking about BSEN 1366 Part 3, which is the fire test standard for service penetrations. So if we look at integrity first, the basic term of this is the ability to resist the fire from getting from one side of the supporting construction, say one side of a wall, breaking through any small gaps to the other side, the non-fire side, or vice versa from the underside of a floor, because we always test floors or ceilings from the underside, breaching through that supporting construction to the non-fire side, space above the floor construction. So that is obviously the important thing. You're trying to stop that fire from breaking through and spreading into another compartmentation area, hence why we discuss compartmentation. Typically when we're doing our fire testing, for those that don't know, and this is why again you need to be wary of certain guidance when you talk about like 40mm pipeworks and stuff, is an integrity will be when there is things like a gap, typically when it's a 25mm, so the test lab can do what's known as a gap gauge, or there's sustained flaming, for example. So this can be done where there isn't a gap or flames appearing. They can even do what's known as a cotton pad test. There's various ways to do it, and at some point I'd like to maybe show this in more detail at a test lab if we ever get the opportunity to. Obviously, most of our testing is successful, so we don't ever have those integrity failures. The second aspect is insulation, and this is the one that causes a lot of confusion. So I'm going to discuss what it is, and then I'm going to go over just the difference between the two. So insulation, we're talking about that from a fire resistance perspective, is the ability or the fire resistance of the sill and the wall or the floor to stop that heat transfer from the fire side to the non-fire side. So when we're talking about it from BSEN 1366 Part 3, it's when the temperature reaches 180 degrees over the starting temperature. So for example, if the starting temperature, because we're in the UK, is 20 degrees, for example, when that thermocouple in the correct positions on the non-fire side reaches 200 degrees, so it's 180 above that starting temperature, that is deemed an insulation failure. So it's not very high, considering the fire in the furnace is likely to be around 1,000 degrees or above. The products are having to stop quite a considerable amount of heat going through. There are other caveats as well, where there's an average temperature of 140 degrees, etc. over all the TCs, but the main one is that 180 degrees. So this is why sometimes when you're looking at Qualifiers details, you may see two ratings. You may see E, which stands for integrity, 120, so that means it stopped that fire for 2 hours through the wall, but you may see EI 60 below it, and this is the insulation, so it actually only stopped the heat for 60 minutes. So this is important when you're looking at your fire strategy, because your fire strategy should determine what your requirements are. Is it both integrity and insulation, i.e. EI rating, or is it integrity only? And understand the difference is important, because when you start having large metal services like cable trays, cables, steel sprinkler pipes, those types of things, which again, going back to earlier knowledge hubs where we're talking difference between reaction and resistance, they are non-combustible materials, metal cable tray, a steel pipe, but they generate heat. Metal is a good conductor of heat. So without additional protection, like foil-faced rock fibre, for example, you can't achieve that EI rating, especially when you're looking at something like EI 120, which happens in some applications. Trying to get that EI 120 can be very difficult. Stopping the fire, relatively easy, but stopping that heat transfer can be difficult. And why this is important to understand in early engagement, again, for something like a cable tray with lots of cables, to achieve EI 120, you may find that it needs to be wrapped in foil-faced rock fibre. Now, this is great from a passive fire protection, and we can achieve that EI 120. What it's not great for is the everyday use of those cables. So again, at the early stage where we're having that early engagement and we advise the MEPs that we're going to be wrapping these trays to achieve that EI rating, they can go away and make sure that the calculations are done on those cables, that they are suitable for their everyday use, because wrapping them up in foil-faced rock fibre can trap the heat and prevent them from doing their everyday job. So again, it's important that all parties have that early discussion to make sure the design is practical for the everyday use of the building, but also the passive fire protection needs. Another thing why it's important to understand the EI is that there can be some times where it's just not going to be possible for the type of service you want. So you may want a certain type of service penetration. Let's talk about conduits, for example. You just want to stick a 25mm steel conduit through a wall and seal it with a bit of sealant, but you need EI 120. Well, if you were to look at, say, for example, QSS FW100-05, page 1, you will see that it actually only gets integrity for 2 hours, but it gets EI 60 for insulation. Whereas if you wanted that 2 hours, you could look at something like a pattress detail. So we could stick firebat and then put some coating on that steel conduit to try and increase the rating, but you may not want the firebat on the face of the wall because of space restrictions. So you may have to look at something like a plastic conduit or something else. So it's important again that when you're speaking to the Quail Fire technical team, you give us all the information, your requirements, and you understand that things may need to be changed. Just because the MEP wants a certain type of service or application, when they're going through compartmentation lines, it may not be feasible. And again, it's understanding that element that will make sure your project is going to be successful moving forward. If we look at this detail here that's on the screen now, this is a copper pipe and it's going through a wall. And as you can see around the pipe, it's just sealed with QuailStop acrylic sealant. Now, if we just had the pipe with a QuailStop acrylic sealant, this would be as per this detail, which is QSS FW75-03. And as you can see, this provides integrity only for a lot of applications. So yep, you've got your copper pipe through the wall just sealant and you've sealed it, but it's not going to be stopping that heat transfer. Copper is an extremely good conductor of heat. So as I just switch this round, you see I'm just moving the foil-faced rock fibre. To combat this, by simply just adding a certain length, in this case 300mm of foil-faced rock fibre, you will see that this detail now, which is QSS FW75-02, greatly improves the insulation rating. So just by having that simple product can achieve your achievement. But again, thinking about this from a budget aspect, if you've only accounted for sealant at the start of your budget and then you're starting to add additional products to meet your fire strategy, you're going to go over budget. So again, the importance of early engagement is to find out what you need, so you know what products are going to be required, so you can budget accordingly. So you're going to be coming in on time, you've got a compliant build, it's safe, and more importantly, obviously for your budgets and next projects, you're going to come in under that budget and be able to keep everyone happy, the clients and everyone. But obviously fire safety, life safety is always important first. So that's basically what integrity and installation is when we're talking about service penetrations. It is important, I said, the fire strategy. A lot of the time, Quail Fire's technical team will just get 60 minutes fire rating. That doesn't really mean a lot to us. So I will say what we do as a technical team is we always base this on worst case performance. So if you just say 60 minutes, we're going to assume it's EI 60 that's your requirement, because we want to make sure that you've ticked all the boxes to say. So it is important, if you have a specific scenario, it might only be integrity only, which can happen. It's important to let us know, because it can change the application and can mean that you don't need to use as many Quail Fire products. Probably a little bit too much to talk about in this short video, but if you do want more information, want to talk to us, there are extra guidance out there by other organisations, but do feel free to reach out to Quail Fire's technical team. We're always happy to help and share our knowledge, and hopefully this helped a little bit.